Physics Part 233. The induced charges will stop moving when the top fields are equal and opposite. Hence, there is no resultant field in a conductor. This effect may be used to charge a body by induction. The process is illustrated in the figure if a positively charged rod is placed near an insulated conductor. Induced charges appear on the conductor, as shown in the figure. If the conductor is now earthed, as is the case in the previous figure, electrons move from earth to neutralize the induced positive charge. The electrons are held in a position by a positively charged rod. When the earth connection is removed, the negative charge is still held in position by the positively charged rod, as is the case in the figure provided. Well, removal of the charged rod means that the electrons will distribute themselves over the surface of the sphere as provided in this figure. Note that if a positively charged rod is used, the final charge in the sphere is negative. If a negatively charged rod is used, the sphere becomes positively charged. The electric field strength at a point is defined as the force per unit charge acting on a small positive charge placed at that point. If the force experienced by a positive test charge plus Q placed in the field is F, the field strength is E, is given by E is equal to F over Q. Be careful not to be confused by the symbol E for field strength. E may also be used for energy. A unit of field strength can be deduced from this equation. Force is measured in newtons and charge in coulombs. So the SI unit of field strength is NC. We shall see later that there is another common SI unit for electric field strength, Vm. These two units are equivalent, uniform electric field. Well, in the figure, we can see the electric field pattern between the parallel planes consists of parallel equally spaced lines. Except near the edges of the plate, this means that the field between the charged parallel plates, as for example in a capacitor, is uniform. The figure illustrates the parallel plates at a distance d apart, a potential difference V between them. A charge plus Q in the uniform field between the plates has a force F acting on it. To move the charge towards the positive plate would require work to be done on the charge. Work is given by the product of force and distance. To move the charge from one plate to the other requires work W, given by W is equal to Fd. From the definition of potential difference, W is equal to VQ, thus W is equal to Fd is equal to VQ, or rearranging F by Q is equal to V by D. But F by Q is the force per unit charge, and this is the definition of the electric field strength. Thus, for a uniform field, the field strength E is given by E is equal to V over D. This equation gives an alternative units for electric field strength. Remember that we have already derived NC from the idea of force per unit charge. If we use the expression for a uniform field, the unit of the potential difference is volt, and the unit of distance is the meter. So another unit for electric field strength is volts per meter, Vm. The two units NC and Vm are equivalent. Example: two metal plates 5.0 centimeter apart have a potential difference of 1000 volts between them. Calculate the strength of the electric field between the plates. Calculate the force on charge of 5.0 Nc between the plates. Calculate from E is equal to V over D, E is equal to 1000 divided by 5.0 into 10 to the power raised to minus 2, 2.0 into 10 to the power raised to 4 Vm.